Hi guys, this is your video for review for topic 3, which is operations with rational expressions. This tends to be the topic that you guys have the most trouble with. So the first two questions are pretty basic, and then we're going to get into those longer problems that involve a lot of factoring. Okay, so question number 1 says, what is the least common denominator of these first fractions? So always where we're going to start in questions like this is we're going to factor the denominators or write them in their prime factorization. So that makes this a little bit easier for us because the first denominator, which is 2, is already written as a prime factor, which is 2. The second denominator, 5x, you can write that as 5 times x. And the last denominator is just x. So what I like to do to come up with the least common denominator is take one of each of the prime factors. So we want distinct factors that we're going to use. So I'm going to take 2 as the first part of my least common denominator. I'm going to take 5 because that's distinct. It's different than what I have already, different than the 2. Take x. Again, that's distinct. And then my last denominator is a single x, but I already have a single x right here. So I don't need to repeat it because I've already taken a single x out of the denominators. So if I multiply what I have together, that's 10x, and that is your least common denominator. Okay, question 2 is, it's a solving problem, but they're not asking you to solve. All they're asking you to do is to determine any excluded solutions or restrictions that you would have. So we know that when we solve a rational equation, there are some values that I'm not allowed to have because when I plug them back in, they'll give me an undefined value. So what I'm going to look for here is the denominators. So I see 2 denominators. I've got x plus 1, and my other denominator is x plus 9. And what I know about fractions is that I can't have 0 in the denominator. So x plus 1, the value of that denominator can't be 0, and x plus 9, the denominator of that, the value of that denominator can't be 0 either. So you solve each of these like regular equations. Subtract 1, and I get that x can't equal -1. And here I get that x can't equal -9. Okay, so those are my restrictions to the equation, and they're also values that if I were to solve, I would have to exclude. They would be extraneous solutions to the problem. Okay, so here we have these tougher problems that we've been working with, which are to perform the indicated operation. And these we tend to have trouble with just because they involve a lot of factoring. So you have to be really good on your factoring rules in order to be successful with these types of problems. So for the first one, this is just a simplifying problem, meaning that I should factor the whole numerator, factor the whole denominator, and see if there's anything that simplifies. So I'm looking at the numerator, and I see that this is a difference of 2 perfect squares. So 4 minus x squared, it's a difference because there's a minus sign in between, and 4 is a perfect square, and so is x squared. So that factors into 2 plus x and 2 minus x. Okay, and the denominator here is just a regular quadratic polynomial, a regular quadratic trinomial rather. And here I want to see what multiplies to 6 and adds to 5 to get that factor. So that's x plus 2, x plus 3. Okay, so before I go cancel happy here, we want to take a second before we cancel to write down the restrictions. Looking in the denominator, I know that a value of -2 would make my denominator 0, and a value of -3 would make my denominator 0. So those are my exclusions or my restrictions from the function. Now I can cancel. So x plus 2 and 2 plus x, because we know multiplication is commutative, that cancels. My final answer is 2 minus x over x plus 3, where x can't equal -2, and it can't equal -3. Okay, so that's a basic simplifying problem. No in particular operations that I would be using here. In the next question, this is a subtraction problem. So subtraction problems are, again, started by factoring and stating the restrictions, so we'll do that first. The denominator is what we want to factor out so that we can see what our least common denominator is going to be. So again, difference of squares on the first denominator. That's x plus 2, x minus 2. And then my next denominator just has a GCF of a 2, which gives me an x plus 2. Okay, so we're going to do something called building up the denominators, which means looking from one fraction, so looking from the first fraction to the second fraction to see what the second fraction has that the first doesn't in the denominator. So I'm looking over and I'm seeing that there is a 2 in this denominator that my first fraction doesn't have. So I'm going to multiply by 2 over 2. Remember, the reason why you're doing that is because you're not allowed to change the answer. You're not allowed to change the function. So by multiplying by 2 over 2, I'm essentially multiplying by 1 and not changing what I have, but I'm still getting what I need from the problem. In looking at the first denominator, I see that they have the 2 in common, so that's good to go. They have an x plus 2 in common, good to go, but I'm missing an x minus 2. So again, I'm going to get that on top and bottom. And now I'm going to start to make the fractions. So I have 6 in the numerator over 2, x plus 2, x minus 2, minus, and then if I multiply these two binomials together, I'm going to get x squared minus x minus 2 over 2x plus 2, x minus 2. And if you notice at this point, the denominators are the same. So the denominators being the same means that I can now combine the fractions. So 6 minus, be careful of your parentheses here, minus x squared minus x minus 2 over the same denominator, 2 x plus 2, x minus 2. And we're just going to simplify. So I have 6 minus x squared. Oh, this shouldn't be an x squared. That's a regular x. Plus x plus 2 over 2x plus 2, x minus 2. So we're just going to combine like terms, and we'll get negative x squared plus x plus 8 over 2x plus 2, x minus 2. And now that we're all done, quickly look in the denominator, and I'll notice that my restrictions are that x can't be negative 2 because that would give me 0 here, and x can't give me positive 2 because that would be giving me 0 there. Okay, so in this next problem we have down here, this is a division problem. Again, we're going to start it the way we start everything. We're going to factor everything out. The first numerator I have is a quadratic trinomial, so I need to find out what multiplies to negative 24 and adds to 5. So that's going to be x plus 8 and x minus 3. Denominator is 3x divided by, this one is a binomial, so that one just has a GCF, which is 3x cubed, and you're left with x plus 2 in the numerator. And the denominator here is x squared minus 6x minus 9, meaning I would need something that multiplies to negative 9 and adds to negative 6. But in reality, we don't have something that does that. We don't have a pair of numbers that can do that. So you cannot factor that denominator. Okay, so the biggest mistake that we're going to avoid now is start to cancel things out, because this is division. And if you remember, in division of a fraction, you have to keep, change, flip, right? So this is not the problem as it's ready to be done. You do want to stop and take a second and state the restrictions here. This restriction would give me an imaginary number, so don't worry about that. This one is just to say that x can't be 0, so make sure that you know that x can't be 0. And then you can continue on with the problem with keep, change, flip. So you have x plus 8 times x minus 3 over 3x times, and now flip the fraction or multiply by the reciprocal, x squared minus 6x minus 9 over 3x squared times x plus 2. The only additional restriction that I see here is that x can't equal negative 2 as well. This again would give me 0, but I already wrote that, so we don't have to repeat ourselves. But if you notice, nothing here cancels, because to cancel you need a pair in the numerator and a pair in the denominator, and we don't have that, an identical pair in the numerator and denominator to cancel. We have identical pairs, like I have a 3 that's right here and a 3 that's right there, and I also have x's, but the rule is that it needs to be in the numerator and denominator. It essentially has to be a division problem to simplify, and I don't have that here. So this is as far as I can go with my restrictions, and that's all we can do there. Okay, here's our very last problem, which is an equation, a solving problem. And here's another place we're going to start by factoring denominators. So we have x over x minus 2, nothing in that denominator factors, plus x over 4 is equal to 3x over, here I have a GCF, I have a GCF of 4, so 4x minus 2. Okay, so you want to state two things before you go any further. I want to state my least common denominator and my restrictions. So least common denominator, I'm going to take distinct factors from the denominator, so different ones, don't repeat anything. I have x minus 2 from the first fraction, I have 4 from the second fraction, and then the third fraction here, you'll notice that that has a 4 and an x minus 2, so I don't need to repeat anything. That's my LCD. And my restriction, the value that x can't be, is x can't be equal to 2. Okay, so what I need to do here to solve is I'm going to multiply both sides of the equation. I'm going to multiply both sides by 4 times x minus 2, and that's going to serve to eliminate the entire fraction. So if I multiply the first fraction times 4 times x minus 2 times x over x minus 2, that will cancel the x minus 2's, plus, I'm going to go on the next line here, 4 times x minus 2 times x over 4, that cancels the 4's, is equal to 4 times x minus 2 times 3x over 4 times x minus 2. So that cancels both 4 and x minus 2. Oh, I'm just going to move my work over here so I can work underneath. Okay, so what I'm left with then is 4 times x plus x times x minus 2 is equal to 3x. Just go ahead and simplify so you have no parentheses left. 4x plus x squared minus 2x is equal to 3x, which gives me x squared plus 2x is equal to 3x. And this step tends to confuse a couple of kids, but you want to remember that quadratics we always solve by setting equal to 0. So I'm going to do that by subtracting the 3x from both sides and getting x squared minus x is equal to 0. Take out a GCF here, x times x minus 1 is equal to 0, and by zero product property, we know that x is equal to 0 and x is equal to 1. Because my only restrictions are that x can't equal 2, these are my final answers.